Welcome back, ladies and gentlemen. Today we're going to be talking about comparing linear functions. This is the idea of when we have two linear functions that are related. In this case, we're talking about earnings. How can we compare the two to see which one is a better decision to make? Which one's going to lead to a better outcome? Because remember, a function is all about the idea of I'm going to put this in and I'm going to get this out. And when we're talking about earnings, you're really talking about how much money are you going to be making. So you can decide how much you have on your grocery bill, how much you can spend towards a car, how much you can spend towards rent. Can you go to the movies? You can make all those decisions with your money because you know that right now you're making the best choice to produce money. All right. So the earnings, Y dollars, or Y in dollars of nighttime employee working X hours is represented by the function. Again, that word tells us it is a line, and if we can expect one outcome for every one input we make. So here's the function. That's my nighttime employee. So Y equals 7.5x plus 30. If you want to know how to read this equation, what it means is you're making $7.50 per hour. Okay, that's our rate. It's also our slope. Keep that in mind. But you're getting a bonus of $30 for working that night shift each time. So the table shows the earnings of a daytime employee. Oh, let me back up real quick. That 30 is each time. I don't know if that's pay period or day or what, but you start off at $30 and then from there you're going to make $7.50. I would guess that's per pay period. All right, the next thing we're going to do is we are going to turn this table into a function as well. Remember, when we're talking about the idea of comparing, we have to have the same representation so we can actually look same to same and compare apples to apples. Right now, we're talking about fruit in general because we have an equation and we have a table that's fruit. They're both in the math category. What we have is apples and oranges. What we have to do is turn our oranges into apples. Mathematically, we can do that. Real world, good luck. So, what we're going to be doing here is trying to figure out what equation can I make out of this. What I need to do is figure out the pattern that's happening. So this is adding 1, this is adding 1, and this is adding 1. Now, that's our x, by the way. So this is increasing by 1. And then we have $12.50 to $25. This is adding $12.50. And then to go from 25 to 37.50 is another 12.50. And to confirm my pattern, 37.50 to 50 is $12.50 as well. So I'm changing by increasing by $12.50 every hour. Well, y and x. I can use that for my slope. The change is what I just found. The change is $12.50. That's y. So I have my slope equals $12.50 over the change in x, or in this case I found 1. So $12.50 over 1 is just $12.50. And that's for every hour. So that can change. I don't make just $12.50. That changes per hour. Now, it doesn't tell us there's a bonus to start off with. In other words, it doesn't tell us there's a base salary like this does with 30. That's a base salary or a bonus. Here, we just have $12.30. So this is our function according to the table. What we're really looking for is the slope. Now, first thing we did, which employee has a higher hourly wage? The slope tells us that. That's why it's the first thing we want to look at. The one with the higher slope, in this case, has a higher minimum wage. Slope is usually what we're going to look at when we're comparing one rate to another, whichever one has a higher rate, because remember, slope is a rate of change. They share a rate for a reason. They're both rates. So we need to know which one's a better rate. The better rate is a daytime employee. So my answer, which employee has a higher hourly wage? That is the daytime employee. But here's the thing. This guy may actually make more than this one. or vice versa. We don't know because right now we have a constant 30 and don't have a constant here. So what we want to do is we kind of want to picture this. We're going to graph this one. So that means I'm plus b, y equals mx plus b is where my y-intersect is. And then I'm going to go up 7.5. Well, here I don't have 7.5, so I want to realize two 7.5s go into 15 once. So that means I actually have to go up 2 times. And then that means I don't just go over 1, I go over 2 because, again, this is the same thing as 7.5 over 1, but I don't have 7.5 in my scale. So that means it's the same thing as if I multiply this by 2, I get 15. I do have a scale of 15. So that means what I do to the numerator, I got to do the denominator, and I can make a like fraction. We're used to simplifying down, but here I'm multiplying up to make it match my scale, and that's very important. It's a good idea to do. Now, if I do that again, in other words, I'm going to take this same, go up 15 over 2, I get my third point, and now I'm able to take my straight edge, which in this case I'm going to be using some passes, and I'm going to line up and then draw. And there's my graph. So now I have graphed this function. Done. Next thing I want to do is I want to graph the other function, and we're going to find something here pretty soon. It's actually pretty cool. So what I want to do is 12.5 is somewhere around here. I want to keep multiplying that because, again, that's 12.5 over 1 is this slope. Well, if I multiply that by 2, I'm going to get 25. That's still not on my scale here, but it's a lot closer to being on there. And that would be by 2. So multiply by 2 again, maybe. And I'm going to get 50 over 4. I don't have a 50. Now, if you keep noticing, I'm going to have trouble finding this exact slope. So our trick over here doesn't work as easily on this problem. What we are going to be able to do is thinking through it and using that slope. Give me a second. What we need to realize is, my brain stuttered, so I was looking over my notes, is that since this is a direct, and I know we didn't go over it greatly, but since this is a direct proportion, it means it goes through the origin right here. That's definitely 1 point. And then all I have to do is really solve or plug in, I call it plug and chug, plug in any of the values for x. So if I wanted to, I could sit there and say, okay, pick any value, and I should be able to plot it. I'm doing the math in my head, sorry. So what I'm doing in my head is I'm figuring that 12.5 times 6 should be on my graph. And again, I did that in my head because I'm trying to save time. Times 6 equals 75. And so I look and I see 75 is here. And so is 6. So now I know I say do 3, but in this case, for time issues, you've seen that I'm making correct straight lines. All right, there we go. So this graph, what it's telling, and remember, doing the math in my head, I was realizing that doing by 2s, I was never going to get there. So in my head, I did 3. I went 1250 times 3 is going to be 3750, not on my scale, but if I double that, I get 75. That's how I got 75. Again, that's how I did it in my head. So I knew double 3 is 6, so 1250 times 6 is 75. Connecting my lines, and this graph represents your pay at $12.50. What this graph is telling us, because remember, we're comparing, what the graph is telling us is I will actually make less money at the end of the day until I work 6 hours, because the orange graph is always below the blue graph. My goodness, I couldn't think of the color. The orange graph being below the blue graph means I'm making less all the way through here, every second of every minute of every hour until I hit 6 hours. Then I'm going to be making the exact same amount with this pay during the daytime as I do at the nighttime. After 6 hours, I'm actually making more than somebody working the night shift. So just because our slope was bigger does not necessarily mean that means you're going to make more money. It depends on the function of your pay. So here, if all you do is work 6 hour shifts, it doesn't matter which job you choose. If you're going to work less than 6 hours, it's better to work at night. And if you're going to work more than 6 hours, it's better to work during the day if your goal is to maximize how much money you're making in each paycheck. So if you have any questions, email those to me. Stay safe out there, guys, and we'll see you in the next class.